35 says solve by graphing. Can I begin to graph these equations as they are?
No.
Why not?
Slope.
Yeah, we need them in slope-intercept form, which is y equals mx plus b. So how do I get these to slope-intercept form? Thank you. So if I rewrite 2x plus 3y equals 9, what am I trying to isolate if I want y equals mx plus b? Isolate the y, get the y by itself, which means I need to move what? Taiwo, are you with us? I need to move the 2x. How do I move that mathematically? Subtract it. So subtract 2x over here, subtract 2x on the other side of the equal sign. Okay? So 3y equals, I'm going to put my x first because they do not combine. And then to isolate that y, I need to divide by 3, divide this by 3, divide this by 3. So y is equal to negative 2/3 x plus 3, right? Check my math. Did I do that correctly? Okay. So let's go ahead and graph this. How do I start to graph this now that it's in slope-intercept form? Yeah, the 3, that's your y-intercept. You always start with the y-intercept, which is your constant at the end. Okay? And then it tells me in my slope, I need to go down 2 and 3 to the right. So down 2, 3 to the right. New point. Down 2, 3 to the right. How many points do you need to make a line? Negative 2/3. How many points do you need to make a line? 2. If you put 3, it usually kind of makes your line well, if you don't have a ruler, it's more helpful. But if you have a ruler, you're probably fine with 2. Okay? All right, so that's only the first one. Now, let's do the second one. Negative 4x minus 6y equals negative 18. I'm trying to isolate the y. So, Aaron, what would I do here mathematically? Trying to solve for y. Okay, I should add 4x to both sides. So x's cancel out, and negative 6y is equal to 4x minus 18. I'm solving for y, so divide by negative 6, divide by negative 6, divide by negative 6. Y is equal to negative 4, 6. That's going to simplify. Rashana, come on, put that phone away. What is it with the phones? I should count up how much money I would make every time I call someone out for a phone. I'd probably get $25 a day, at least. You think? Negative 2/3 x and negative 18 divided by negative 6 is plus 3. So let's plot this second equation. What's my y-intercept? 3. Oh, same point. What is my slope? Down 2 over 3. Down 2 over 3. Oh my gosh, Miss Didi, it's the same line. Mon Dieu, what the heck does that mean? I don't know, but okay, I guess we got to solve this algebraically. So now I have those two equations. I need to solve them algebraically. As you look at them, 2x plus 3y equals 9, and negative 4x minus 6y equals 18, negative 18. Should we use substitution, or should I use elimination linear combination? Yeah, elimination, linear combination. So as I look at this, what would you suggest? Let's say we want to get rid of what? The x's or the y's? The y's. Okay, so if this is negative 6y, let's get this to be a positive 6y. And what can I multiply all of this by to give me that 6y that I need? 2. So 2 times 2x is 4x, plus 2 times 3x is the 6y, and 2 times 9 is 18. Wow, this is looking funky. So when I add them together, 4x and negative 4x gives me 0. 6y and negative 6y give me 0. And 18 plus negative 18 is 0. So 0 equals 0? Is that true?
Yes.
Yeah, so what does that tell you, or what does that mean when you have the same number equals itself? Yeah, what if it comes out and it's always the same? That is a good question, Miss Thede. It means you have infinite number of solutions. Okay? Infinite number of solutions. And how can we look at that by the graph? Well, if it's the same line on top of itself, every point on that graph is a solution for both, right? So no matter where you put this, and lines go on forever, you have infinite number of solutions. Okay? So if you have 0 equals 0, 1 equals 1, negative 5 equals negative 5, you're talking about infinite number of solutions. If I say x equals 1, that is one solution, okay? And if you say 0 equals 3, is that true? No, so that would be no solution. All right, no solution. So 0 equals 0, it's always true. X equals 1, true for 1. 0 equals 3, not true. There you go. So our solution is that they are infinite number of solutions. Are they consistent or inconsistent? Okay, this is time for a definition. So somewhere at the bottom, we need to write consistent equations have infinite number of solutions. Consistent equations, infinite number of solutions. Inconsistent, T-E-N-T, yes. They have one solution. Okay? So consistent, think about, well, one line on top of itself, it's consistent, it's got infinitely many solutions. Inconsistent, they have one solution. So in this case, these are going to be consistent. All right? Dependent or independent? So another definition here. Dependent equations, and honestly, I need to look this one up. This is not something that I don't think I ever recall that I was taught until we got to this course. So I want to make sure. Well, if I could find it on my desk. I want to make sure that I'm telling you accurately. That's not a notebook up there on the Promethean board, is it? Or a workbook? Is it a stack of papers? Okay. Okay. Where? Here it is. Here it is. Okay. independent has exactly one solution. Independent has exactly, okay, so I said dependent. Dependent has infinitely many solutions, and independent equations have one solution. Okay, you guys are gonna kill me. Kill is a very strong word. I was wrong about consistent. Consistent, it's not equations, it's systems. Consistent systems have at least one solution. So I was totally wrong on that one. It's just not something that's in my wheelhorse, and I apologize. Consistent systems have at least one solution. Okay? They have at least one. And erase, don't worry about the inconsistent. Thanks for screwing that all up, Miss Sadie. You're welcome. Shows that I'm human too. Teachers are human too. So one more time. Consistent systems have at least one solution. So this is still consistent. And independent has one solution. Dependent has infinitely many solutions. So this is dependent equations. All right? Any questions about that? Okay, let's go to the next page. Erase. Page 36. So we have two more equations. We need to solve by graphing and solve algebraically. Okay? So let's see. You guys tell me. Hopefully you're okay for a second here. You guys tell me what I need to do to put this in y equals mx plus b form. Starting with x minus 2y equals 8. So I want to isolate y, get y by itself. What should I do here? What? What about the x? Subtract. Yes, subtract x. Whatever you do on one side, you do on the other side of the equal sign of the equation. X's cancel out. Negative 2y is equal to negative x plus 8. All right. I don't want negative 2y. I want just y. So what should I do here? Divide by negative 2. Divide by negative 2, divide by negative 2. So y is equal to negative divided by negative is positive 1/2 x minus 4. Do you agree? Okay. So that's the first equation. Let's go ahead and plot it. What's my y-intercept here? Negative 4. So 4 down. And my slope is 1/2, so that is up 1 and right 2. This is my y-intercept. So up 1, right 2, up 1, right 2, up 1, right 2. Connect those with a line. All right, now let's take a look at the second one. Is that 3x? I think so. 3x minus 6y equals 6. What am I trying to solve for? Y again, yes. So I need to move my x's. How do I move those mathematically? Subtract. Minus 3x, minus 3x. This is good old algebra practice here. Negative 6y equals negative 3x plus 6. Divide by negative 6, divide by negative 6, divide by negative 6. Y equals negative divided by negative is positive 1/2 x. And 6 divided by negative 6 is
-1.
minus 1. So here is my second equation. What's my y-intercept? -1. And slope is 1 up and 2 to the right. 1 up, 2 to the right, 1 up, 2 to the right, 1 up, 2 to the right. So what do you notice here? What do we have here? A parallels, right? Isn't that cool? Parallels, like the small L's, parallel. Yes, we have some parallel lines. So what do we notice? We notice right away we have parallel lines. Parallel lines. We do need to solve algebraically, it says. So let's go do that. X minus 2y equals 8, and 3x minus 6y equals 6. Should we use substitution or linear combination here? Linear combination or elimination, right? We want to add these together. Which one do we multiply with a number, and what number? Multiply the first one or the second one, and by what amount?
The second one by -3.
The second one?
No, the first one.
First one by -3. What do you guys think of that? Okay. -3, -3. So I'm going to rewrite it above. -3 times x is -3. -3 times -2y is plus 6y. -3 times 8 is -24. So this middle equation is gone. Now I can add them. So -3x and 3x, what happens with those? They cancel out to be 0. Oh, what about the 6y and -6y? Another 0. And then I get -24 plus 6. What does that equal to? -18. So I get 0 is equal to -18? What? So remember how just before in the slide before I said if you get some number equals another number, what does that tell you? There's no solution. And why is there no solution? Because these linear equations, these linear graphs are never going to cross. Yes? What's the what? Oh, yeah, that's way up there, isn't it? It is 1/2 minus 1. 1/2 x minus 1. Okay? So, solution, there is no solution. Now, there's a couple of different ways you can say no solution. You can say no solution. You can also put a 0 with a slash mark in it, and that means null set. There is nothing. Okay? So, the question then at the bottom, is this a consistent system or inconsistent? And honestly, I need to look back. Consistent says has at least one solution. So we don't have any solution, so it is inconsistent. Okay, and dependent or independent? It is one solution has infinite. Dependent says it has infinitely many solutions. Independent has one. Do we have either one of those here? No. So it is neither or neither. It is neither dependent nor independent on that one. Hey, Will, is that your music? Will, is that your music? It's a little loud. Just turn it down. Any questions about that one? All right, let's go to the last one. Last one. Let's actually do it algebraically first because it's written here nicely and we can do that and we can graph it elsewhere. So as I look at these, how do you want to solve this? Do you want to do substitution? Do you want to do linear combination, elimination? Yeah, I think that's almost easier too. How do you want to work that? Work it, work it. How are we going to work it? Come on, people. Multiply the top one by 3. We could do that. Yeah. There's other things we could do. We could multiply the top one by -1 to get rid of the y's. We could multiply by, you said 3 on the top. That works. That works for me. So let's multiply by 3. So 3 times -x, -3x. 3 times y, 3y equals -6. So this is no longer here. I can add these together. I get 0 plus 4y equals -4. 0 plus 4y is that 4y. Divide by 4, divide by 4. Y is equal to -1. Am I done? No. What do I do now? Substitute. Yes. Take this value and substitute it back in. You should use one of the originals, and the easier original, I would say, is the one that I crossed out. So substitute that back in and say that is -x plus my y, which is -1. Shoot, I wish I could read that. Is that a -2 or a 2? I think it's a 2. Equals 2. And this is a 1. Erase. Come on. Oh, I just erased the whole thing. So to solve for x, add 1, add 1. So if -x then is equal to 3, x must be equal to -3. Yeah. Divide by -1, divide by -1. X is -3. So, say that again. Is it a -2? Oh, darn it, it is. So then, thank you for catching that. -2 plus 1 is -1. And that means x is equal to 1. Right? Okay. Thank you. All right, so what's my solution? What is my solution? You have an x value and a y value. Right here, what's my solution? We've solved it algebraically. Can we put it together? I mean, you're talking about 2 linear equations. Well, if we're not really sure, maybe we should graph them. So let's go ahead and graph them. Let's see. We have -x plus y equals -2. I want to isolate y. So I'm going to add x, y is equal to x minus 2, right? Okay, so that puts me at a y-intercept of -2 and a slope of 1 in front. So up 1 over 1, up 1 over 1, up 1 over 1. It's almost like a song. Okay, there's one line. So this is my first equation. And the second one, 3x plus y equals 2. I want to isolate y, subtract 3x, subtract 3x. Y is equal to -3x plus 2. So here, my y-intercept is 2. And what's my slope? It is -3, so that means I am going down 3 and 1 to the right. So down 3, 1, 2, 3, 1 to the right, down 3, 1, 2, 3, 1 to the right, down 3, 1, 2, 3, 1 to the right. Okay, again, you only really need 2 points for a line. And what do you notice? They are intersecting. Where are they intersecting? 1, -1. Look at our values for x and y. What were those values? 1, -1. Since this is a point, our solution is the point 1, -1. So when you end up getting x equals a value and y equals a value, that means those two equations are going to intersect at one spot. So they can intersect in one spot, they can intersect in infinitely places if they are one on top of the other or they are parallel lines. Okay? All right, so is this system consistent or inconsistent? I still don't remember this. Consistent has at least one solution. So is this consistent or inconsistent? Consistent. And are the equations dependent or independent? Independent has one solution. That is correct. Has one solution. Okay. All right. So that gave us a little bit of algebraic practice in doing elimination, linear combination. It also gave us more practice with the graphing. So that's good. Any questions about anything on 35, 36, and this should be 37. Okay. Oh, it is quiz time. Yay. So this is the quiz, the pre-FAL little quiz that I give you. And it doesn't count for a grade, but it's going to have me match you up with people that think similarly to you or give the same kind of energy. Okay, so just do your best and you will get a partner that hopefully thinks similarly to you or matches your energy. Okay, does not count for a grade. All right, and whenever you are done, just put it in that basket and we'll call it a day. What day shall we call it? I think we should call it Friday. Yay, it's Friday. Friday. Please put your name on it. There is not a spot for your name. Just do your best. Fine. And did everybody in here get one of those trifold with how to solve systems of equations? I think everybody that's here did. Again, put your name at the top. Even the period at the top would be great. Fifth period. Yes, ma'am? Oh, you need it? That's right. I think there's 3 there. Yes, ma'am? You need to go too? Okay. 1, 2. This? No, you're doing it right now. You have until the end of the class period. This is just matching you up with someone who thinks and works like you when we do the card sorting, which will be probably sometime next week. All right. You want me to read the directions? I'm happy